Second day of discontinuities. The first day we talked about vertical and horizontal asymptotes, which are unfortunately non-removable. A couple days ago we briefly talked about, and I mentioned it extremely briefly, something that is removable. It's something that you can actually cross off if you have them line up right. And so what are actually removable? What are they called? I told you a couple days ago. Well, non-removable obviously then are the, I already told you that one, asymptotes. You can't remove them. Yes, very good. Non-removable are the holes, or removable are holes. So non-removable asymptotes, that means they're going to be there no matter what. But removable are then called holes. Now, here is a big one. When factors can be canceled out, we get holes in the graph. Okay? See how the answer was right down there? Yeah. Always look for factors that cancel out when working with rational functions. That should be the first thing you look for. Not second, not third. It should be the very first thing you do every time. Remember, what's it mean by a rational function? In this case, it means there's a variable in the denominator. Because it might end up that there's not a variable in the denominator once you cross things off. Okay, so it might just be looking like a rational function. So let's go determine any holes in the following function and then sketch the graph. Do you see anything that is factorable? Yes? X squared minus 9 is a difference of two squares. And you were taught basically, well, what's the square root of x squared is x. Now this only works when it's a difference, meaning it has to be subtraction, right? And then you take the square root of 9 and you know that that is 3. And it only works when they're both perfect squares, right? For example, if that was an 8 right there instead of a 9, we wouldn't be doing this. And then all you get to do is pick plus for one of them and a minus for the other. And it really doesn't matter which one. So that's what your numerator is. So in other words, if I multiplied that out, I would get x squared plus 9, right? And on the bottom we have x plus 3. Because do you agree that this is a rational function as it looks right now? There is a variable in the denominator at this time, correct? But that variable that's in the denominator will be going away pretty soon. So was it removable? Yeah, that's the whole idea. And what you do then is you say, okay, well, I see this x plus 3 here. I can cancel that. But what that is there is then a hole at whatever makes that equal 0, which is negative 3. The reason is it still a problem to try? If you tried an xy table and you go back to the original, can you substitute in negative 3? If you go back to the original, will it allow you to substitute that in? It won't, will it? It'd be a 0 on the bottom. Okay? And in fact, it'd be a 0 on the top. But the one that's the biggest problem is when it's a 0 on the bottom, it is undefined. Yes? Say that one more time. Yeah. Yes, good question. The question is it always going to match that? No. The reason it somewhat matches up here is because it was a difference of two squares, and so I did just get the opposite. But if I had to key number factor the top, it was two completely different factors, that wouldn't have happened. Maybe. Yes, whatever you cross off set equal to 0. Yes. Okay. Yep. So what's remaining? What's remaining? Yeah, so really y equals x minus 3 is what remains. Agreed? It hasn't been crossed off, and do you agree it's still there? So this started off looking rational. Once I found those factors, I found a hole. Do you agree this is no longer rational? It's y equals x minus 3. What is that? That's just a line. So all you have to do to get the graph of this function is graph that and put a hole at negative 3. And do you agree this is a line right here with a slope of 1 and a y-intercept of negative 3? Okay? So I could graph the line in there, but the one thing you have to be careful of is that you do have to put a hole wherever that road, if we want to talk about it like that, wherever -3 hits that road. And do you agree that -3 is pretty much right here for an x value? You look down on that road, you see how there's a hole there. Now, believe it or not, the TI-83s do this very well. But their hole doesn't have a nice little round part like that. It's just all out of nowhere. It just doesn't put a point there, and it's very hard to see. Okay? If you were to graph this one on a TI-83, of course, you would put parentheses around the top and the bottom to make sure it knew what you wanted. But it would actually put a hole there. It's just you wouldn't be able to see it. If you went to the table, it would put error. Okay? It knows that it can't be there. Okay? Yes? I graphed this. This is what was left over. See how it's still there? Okay, it's a slope of 1 and a y-intercept of 3. So go to -3 and then go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. It's a line. Or you could do an XY table if you really felt like it. Okay. So this graph is very similar to the graph of the original function, except this original function has a hole. Or that one. If all I asked you to do is graph y equals x minus 3, it wasn't this problem, you wouldn't put the hole there. But I'm really trying to have you graph this rational function, which is that line with a hole. Okay. So you saw a rational function actually just ended up linear, didn't it? Any asymptotes in that? But was there a discontinuity? A place where you would, if you had to graph this by hand, is there a place where you actually would have had to pick up your pencil? Is it a very, very tiny one? Okay, it is. Now some people, of course, some people say, but couldn't you just go like this and then go around the circle and shoot out the other side? I didn't have to pick up my pencil. Like, yeah, we put the big circle there so you can see it. All right, it's really just a really tiny little gap there. All right. It's as if you poured water at the top here, it would start rolling and it would leak out right there. All right, there is a gap there. All right. So that's example 1. What did I do with example 2? All I did was flip it over. Do you think it's the same graph?
No. Yeah.
Let's find out. Well, so can we do some of the same stuff? Can we still factor the bottom same way we did before? So it's this, right? Can we still cross off a factor like we did before? So then what holds the place of the top for us? A 1, right? There's still a 1 there. And so is there still a hole at the same place there was before? Yeah, I crossed something off. There's still a hole at x equals -3 because you set that equal to 0 and solve it. All that tells you is the x value. It doesn't tell you the y value. What remains this time, though? Remaining y equals, now here's where we got to be careful, 1 over x minus 3. So is it still pretty similar to the one we had before? But last time it was rational that turned into almost linear, right? A linear with a hole. This is rational that stayed rational. Just looks a little different now. So now, once again, if all I asked was to graph y equals 1 over x minus 3, that's something you should be able to do. That's a parent graph, right? The only difference between that one right there that we just wrote down and the original is the hole at -3. Okay? So let's go ahead and take a look at this. Either you can use your parent graph, and let's face that, what's going to happen? We know what the 1 over x parent graph looks like. All that's been done has been moved right 3. Okay? Do you agree with that? It's been moved right 3. Now let's test that with what we learned yesterday. Yesterday, to find vertical, you were told to set the denominator equal to 0, correct? So that ends up at x equals, is that moving at 3 from where we know it was before? Now yesterday you also learned that if the bottom is bigger, there's an automatic answer for horizontal. And this is x to the first, right? And if I had to, it'd be x to the 0 if I had to write one up there. So do you agree the bottom is bigger? Or think of it this way, as x got huge, would this bottom start to dominate? Yeah, actually it wouldn't take long at all in this case, right? Because there's nothing, I say it's a 1 on top, right? So this wouldn't take long for x to dominate this. And so y equals 0 is your other asymptote. Does that agree with our translations that we were doing before? Yeah, it's just moving at 3. It's the same thing. There they are. Now this time you really shouldn't even have to do that XY table because you have a pretty good idea of what this graph looks like, right? But if you wanted to do an XY table, is there anything wrong with that? Not really. Right? You go ahead and you do that. And let's face it, I told you I wasn't going to get too tricky on you, so just pick something to the right of that. So maybe we'll do 4, and something to the left we'll do what, -2 maybe, or something like that? You know, that works, right? So if you put in 4, and what I would do, you can put it in the original if you want, or you can just put it right down in there. So if I put 4 down in there, I get 1, right? And if I put -2 in there, or not -2, but +2, sorry. I don't know why I would want to try -2. +2 would be right, just to the left, right? And so it's -1. So 4, 1. Do you agree the point's right there? So does that tell you what that graph does in that area? Yeah. It goes from here, heads towards that asymptote. And 2, -1. Right there. Does that give you a pretty good idea what happens now? Right? 2 negatives right there. All right, so now I'm going to get done with this, and then I'm going to have you tell me why my graph is wrong. I don't have a hole. What did I just graph? I graphed 1 over x minus 3. Is that what I asked you to graph in this problem? No, I asked you to graph x plus 3 divided by x squared minus 9. And so I did a great job over there in blue of graphing 1 over x minus 3. But all I have to do to make this other graph is put a hole at -3. So we go here, we get our eraser. We go to x equaling -3, which is right about there, right? And wherever that road happens to be going, we just put a hole there. All right. Now we have the graph of what you were actually asked to graph. Any questions on that? Yes. Because look at what we had remaining. Was it rational anymore? Nope. So no more asymptotes. Yep. So basically the key that I gave you these two problems and why I gave you these two particular ones is to show you that sometimes it stays rational and sometimes it becomes more linear. So it is a possibility. Okay. We've already discussed yesterday if the top and the bottom are the same, right? We talked about that? And we also talked about if the bottom is bigger, right? Well, do you agree there is another option if the top is bigger? Then why are there two options? Well, there's two options because the option is possibly that the top is exactly 1 bigger than the bottom. That is a very distinct case. So top exactly 1 bigger than the bottom. Okay, these aren't really good words. Obviously, you know that means numerator and denominator, right? If that happens, you even have a note down below as to what that means if that happens, but I'll just give it to you here. You're going to get a slant asymptote. It won't be horizontal, it won't be vertical, it will have some kind of tilt to it. Like diagonal, I guess you could say. It won't be perfectly horizontal or vertical. So top exactly 1 bigger. Which only leaves us with one more option if the top is more than 1 bigger or a lot bigger, right? And let's face it, if the top's more than 1 bigger, the top's going to dominate this thing, right? It's going to have no. Yeah, then the bottom's bigger. The top is more than 1 bigger than the bottom. This is actually kind of a nice one because no slant or horizontal because the top dominates. There could be. I can't say for sure because you might cancel out some factors and then the vertical would go away. So I can't guarantee. All right? Exactly. The question there was that it might not be any asymptote at all, and that would be correct. Yes?
So this is just your scale. It's 0.5 bigger. Like, it does sound bigger, but it's not.
Oh, I understand. The question is, what if it's a 0.5 bigger? That can happen, but we'll get to that another day. We'll talk about that another day. Yeah, good question, though. Yep. It's a specific case. Okay. Yep. Now I do get the question that you asked before. Yeah, now I get it. And we'll talk about that at another time. Okay. I thought something else at first, and that's why I answered it differently. So let's take a look at these. What do you think? Determine if they have horizontal, vertical, and or slant. And do you notice basically it's either going to have a horizontal or a slant. It's probably not going to have both. All right? So we got x squared over x plus 5. Can we do any factoring? Because remember, I told you always to do that first. Is there any canceling or factoring on a? No, nothing you can do there, right? And so are we going to have a vertical? Notice, am I even asking you to find what it is? I just want to know. And you would just set the bottom equal to 0, right? You can get something, so there is a vertical. Well, is there going to be a horizontal then, in this case? Now, how can you tell? Because the top is 1 bigger. And if the top's exactly 1 bigger, because it's x squared versus x to the first, right? So it's exactly 1 bigger, and so then we know there is a slant. Very good. And all that means is your asymptote might go through the graph like that. Okay, that's all a slant asymptote means. It won't be straight across or straight up and down. It just has a tilt to it. This next one, again, what's the first thing you should always look for? Factoring. Can we factor anything there? No. For one thing, there's a sum on the bottom, not a difference, and 6 isn't a perfect square anyway, so you know it doesn't really matter at that point. Is there going to be a vertical? No, because if you set the bottom equal to 0, you'd be taking the square root of -6, which is imaginary. Look at me, always making you think. It's terrible. So there are no verticals, but there is a slant. And that actually is a rather interesting graph. If you have a graphing calculator, you can take a look at that one. Okay. How about any factoring for C? Can you? No? How about a vertical then? Yeah, there is. That's 0. Yeah. Mm-hmm. Is there a horizontal? Slant? Why not? Yeah, the top's more than 1 bigger. So do you agree as x gets big, this numerator is just going to get way bigger than the denominator? That's why there's no problems, right? And so there's just a vertical, and that looks like vent. I don't know. There. Vertical. It would look like an N, so I just made it bigger. Yeah. Some people would know. Letter D. Any factoring? Yeah, quite a bit actually. That's kind of being annoying on this one. But if you look at the numerator, there's actually one step that you might try key number, and it's not going to work right away. It will work, but it won't work right away because they all have too much. But they all share something. They all share an x. So that's called greatest common factor. So you took it out, right? And then the same thing happens on the denominator, right? Right? So can we do any more factoring in the denominator? No, that's pretty well all factored out. It's very possible I can't factor the numerator anymore either, but we'll go to some scratch paper over here, and we'll take a look at that. So it has to multiply, add, multiply to b, -4, add to b, -3. Do such numbers exist? What are they? -4 and 1? So I'm just going to speed things up because there's a 1 out front. If you're just going for factors, you pretty much just write the numbers down. Remember, the extreme shortcut is if you're going for the zeros, you just switch the signs. Right? So my new numerator is, there's still an x, right? And this has become x minus 4 and x plus 1. Now answer the question. Horizontal, vertical, slant. Cross what off? So this x cancels with that one? So this started rational, correct? It went back to linear. They are our holes, agreed? There's 2 of them at 0 and -1, so they're actually really close together too. But it ended up being a line, so are there asymptotes? You would now look here, it's a line. It's not even rational anymore. So are there asymptotes? No. There's 2 holes. Okay. but no asymptotes. So if you were to answer this question, you'd say none. None of any of them. It didn't ask for holes, but you found them. Okay? So kind of tricky. We might very well save this last one for the next day of class, but you're still going to get your homework.